a proud moment for all of us that we are able to provide every year the annual climate statement for the world bodies, which is taken care of to provide a global statement of climate. We have been able to provide the forecast on the climate developing to commence with the monsoonal rainfall in the beginning of 1900s. Or you can say the past Director General of Meteorology started to provide some kind of technique for prediction of weather, especially the monsoon rainfall. We have been able to provide some kind of discovery towards the meteorological sciences, including El Nino and Southern oscillations, Indian Ocean Dipole, MESO, etc., by the various scientific community in India Meteorological Department. With respect to the current status, we are able to provide all types of weather and climate informations for each and every socioeconomic sector. Perhaps there is no such socioeconomic sector which is left out without the service of India Meteorological Department and the Minister of Earth Sciences. The credit goes to all of you, the entire meteorological community, working anywhere within India and outside. I congratulate on this occasion all of you for your dedicated contribution towards the growth of science and the services with respect to meteorology. Especially when you consider the sectoral applications, the service towards aviation has been in the forefront. And today's eminent speaker, Dr. Tyagi Saab, has made immense contribution towards the growth of aviation meteorology in independent India. And when we talk of the modern meteorology in India Meteorological Department, Tyagi Saab is the person behind. Tyagi Saab is the person who led the modernization of India Meteorological Department in 2008. With his able leadership, we could scale new heights in the recent time, moving from analog to digital methods, moving from subjective forecasting to objective forecasting, moving from only 24-hour forecast to 3 days forecast, moving from accurate forecast to the inaccurate forecast, from the inaccurate forecast. We also have been able to increase our presence in various applications under his leadership during 2008 and 2012. Thereafter also, he has been instrumental in various programs and schemes of Minister of Earth Sciences and India Meteorological Department, and he has been able leader, he is an able mentor, and he has been able inspirator to each and every one in India Meteorological Department, also in the country. He has been instrumental to further the cooperation among the various countries for the growth of meteorology and the services. He has been instrumental for establishing the SAMA, the South Asian Meteorological Association. So we all feel proud, sir, because of your presence today, because of your contribution to the science of meteorology. And we hope your growth, your contribution to the growth of science and meteorology and services in India will continue, and you will inspire each and everyone present here and present online for the success of the journey of India Meteorological Department and journey of meteorology in the country. Thank you very much, sir.
So many of us, even most of us have worked under AVM and Dr. Tyagi Saab, but there are a lot of new entrants in the department, and many have joined from outside IMD also. So I would request Anup to please introduce AVM Dr. Ajit Tyagi ji.
Thank you very much, sir. Now our speaker, Dr. Ajit Tyagi, he doesn't need any introduction. Still, let me do the formality. So AVM Dr. Ajit Tyagi is the chairman of IDC Foundation and patron India Water Foundation and founder president of South Asian Meteorological Association. He has served as Director General of Meteorology, India Meteorological Department during 2008 to 2012. And Assistant Chief of Air Staff Meteorology, Indian Air Force during 2005 to 2007, and Koteswaram Chair Professor with Ministry of Earth Science from 2012 to 2015. He has permanent representative of, permanent representative of India during 2009 to 2013 with World Meteorological Organization and a member of its Executive Council. He played a very important role in formulating a global framework of climate services. He has served as member of governing councils of SARC, Meteorological Research Center Dhaka, and Indian Institute of Tropical Meteorology Pune, and National Atmospheric Research Laboratory Gadanki. He was the president of Indian Meteorological Society for the period 2016 to 18, and he has been a member of scientific committees of MOES, DST, ISRO, MBDA, and WMO. Dr. Tyagi played a key role in the modernization of IMD and brought significant improvements in weather forecasting and warning of high-impact weather events in the country. Under his leadership, agro-advisory services were extended to 640 districts, and Nauka system was implemented during Commonwealth Games 2010, and early warning of tropical cyclone was significantly improved. He has been actively involved in the promotion of meteorological services in South Asian countries, and his area of expertise includes public weather services, early warning of severe weather, aviation meteorology, and climate change. And AVM Dr. Tyagi has been conferred with Vishisht Seva Medal by President of India for his distinguished services.
Sir, we request you to kindly deliver this lecture. Sir, यहीं से
Yes. Fine.
हैं? हाँ, yes. So, sir, all MCs, RMCs have joined to listen you.
Not only MCRMC, other people also.
Other IMS members and other institutions have also joined you, including the aviation services we are providing to them.
Thank you and good morning, and it's a matter of great honor for me to be here. Thank you, Dr. Mahapatra and organizing team who have invited me to deliver this talk. I'm really happy to be part of the 150-year celebrations of IMD, a great institution serving the country very, very, very admirable. In recent years, the advancements have been now recognized not only in India but worldwide. We have a third vice president of WMO with us. So it shows that, yes, international community also. And this wouldn't have been possible without, I think, participation of all of you. So I'm personally thankful to each one of you, the young and the senior one, who are continue to work and contribute and take the IMD to the newer heights. There is no denying that in recent years, IMD has advanced in all aspects. And this wouldn't have been possible without participation of each one of you under able leaderships of Dr. Mahapatra and earlier DGs. With these opening remarks, let me start. Essentially, I am an aviation forecaster, so I felt happy to give this talk. But then when I look back, I had been in the earlier era. All of you advanced so much in aviation meteorology, thanks to the modernization programs which are going on. And so I tell you that when I joined Air Force in 1970s, virtually there was nothing. It used to be just one-man show that forecaster or the meteorologist used to stand on the tower, look around and forecast. It was just after during the Indo-Pak War, so all data from the West was stopped. And we have to provide forecast based on the cirrus clouds or some inputs given by the air crew. So this used to be challenging challenge. There was no automatic weather stations, no radar, no satellite, and you have these products available from Indian centers, the NWP. So everything is there on your plate to provide the services. But all this has happened over a period of time by sustained effort of the India Met Department. It's not overnight that we can advance. And this advancement has contributed through India aviation meteorology to the other branches of the meteorology. So I must say that particularly the local forecasting nowcasting, which is the key activity of the aviation meteorology, has benefited many other services of India Met Department. And this is the forte of aviation meteorology, that yes, we are able to provide good current weather information in real time to the aviators, and also the forecast, which is location specific, intensity specific. So this is a great service which we are providing to the aviation community. So with these opening remarks, let me start. But when I wanted to plan this lecture, I had a background of earlier years and some recent years, which is available on internet. In between the period, I think you know much better than me what is happening in the MHD or aviation services. So bear with me if I am not up to date. In the process, I have learned a lot by reviving my interaction, and so that way it was a learning experience for me. And I'm really happy to see a document which when I looked at the internet to know what is happening in IMD. So the SOP which has come. Next slide.
Right. Sure, but I will next.
Yeah.
Okay.
Sure.
So I'll be covering by brief introduction, which already started, growth of aviation, because our services are linked with what is happening in the aviation sector.
Can someone they are able to see the PPT?
YouTube check. Yes, sir.
Live.
And along with the aviation, side by side, the advancements which are taking place in technology and science, that has contributed to the services. And many things are happening, and we have to catch up and be in tune and in time with what all developments are taking place to keep ourselves abreast. And so this is very important, that we are doing a good job, but then we have to be on toes to take it forward. Next.
Click. Click on.
Okay, so this is the SOP which has come up in 2021 or so. It's very comprehensive. Let me compliment DG and the entire team, which is listed in the next slide, starting from Devnath to the Gajendra to all MWO's representatives. So it covers almost all aspects of aviation. So this is very important part for any service provider to standardize and make it available what is expected out of the staff. And I'm really happy to see this, and many of the things which about the forecast especially, processes and documentation is important, but to instill a good forecasting part in the staff there at the airports is very important, and those guidelines are also provided. So I'm really happy. I'm sure this document is being used by the staff. And so with these opening remarks, let me go to the next slide. So as I told you that right from the beginning, the first when anything happened in aviation, demand for the aviation was felt. And then as it advanced in the aviation, we also have to keep pace with that. And from the aviation meteorology, also the meteorology benefited. So this is one of the oldest service of the IMD, another being the marine service. And well, as I told you, the advancement of the airport services is linked with the advancement in technology and science, both part of it, as we will see next. And it is also a revenue earner for the department. I think this is the only service which brings revenue, and with the advanced services, I'm sure we should be getting much more revenue. Now, this is what shows the growth of aviation. International and national boat traffic is increasing, and number of the airfields, which were just 20 before the independence, has already touched 100. As per unofficial records, there are 130, 140 airfields functional. And then there are joint airfields where the civil aircraft land in the Air Force and Naval um, airports and airfields also. So it makes close to 170, 75 airfields where met services nationally are provided. And as per the projection of Airport Authority of India and Ministry of Civil Aviation, by 2047, the number of airfields will be 300. So we have to start planning for this number, and the passenger traffic will increase from 360 million to 3.5 million. So increase of 10 fold in coming years. And the growth of aviation in India is higher than what is the international aviation, which is at the 5.5 to 6. We are growing at the rate of 8.6%. So in South Asia and India is a rapidly advancing and expanding aviation industry. And for that also the India Met Department has to be ready to provide services. Next. So what we have benefited is from the technology. Observations are the hallmark, I think, most important. If you provide current weather accurate in real time to the aviator, 50% job is done. So this is very important. Of course, the real-time communication, high power computing to process the data which is being there. And of course, all this lead has to be converted into services through forecasting. And forecasting comes based on the science.
Good morning, sir.
Okay, sorry. Yeah. So the growth of aviation and the stages through which it has advanced and associated technology, science, and the services we'll be discussing. So we start with the early days during Second World War, where the military aviation played an important role. Post-World War, expansion of commercial aviation, and in the country post-independence and post-liberalization have been the two landmarks for the expansion of aviation and aviation med services. The future is bright, as I told you. Number of airfields are going to come. Variety of aircrafts will be there for us to provide services. Next.
They're able to listen or not? No, why he's telling something, no, Dr. Datta?
Datta sir, are you listening?
I'm able to hear. I'm able to hear.
Fine.
Okay,
Then you
thank you.
keep in a silent mode. Be in silent mode.
Okay, next. So we started, I think the aviation in the air was the kites in 18th and 19th century. Apart from the recreation and the part of it, the kites also played a very important role in providing the data, instrumented data. So this was the first platform where we could get something about temperature and the winds up to say 2 kilometers or 2.5 kilometers. This was taken over by the balloons, and then the gliders came, and of course, finally by in the beginning of the 20th century, we had the fixed wing aircraft. Next. So these are the highlights of the kite's contribution to the science. Was used by scientific purposes, and the Franklin's famous experiment providing the lightning is there, and then the kites were precursors of traditional aircraft and also historical role in lifting the scientific instruments to measure atmospheric conditions and weather forecasting. So kites may look like a recreational activity, but it did play a very important role, both instrumentation and science and the development of the aircraft. Next. And the balloons first were the hydrogen filled balloons. Again, up to 2000 feet, we were able to get the data, and at the place of launch and neighboring areas. And followed by, we had next gas filled balloons, which had longer duration and that continue for next 200 years. Now, even now, the gas balloons are being used in sports activity and recreational activities. And also the teaser balloon, which we'll see here next, is used for observations in the field experiments of the in the boundary layer. So all these balloons have provided us very useful information about the atmospheric conditions. So also contributed to the understanding of the local weather. Next. These are the teaser balloon which provide fixed with the wire, and at different levels you can take the as it lifts up observations. Next. The glider is the unmanned vehicle, and this again is used in sports, paragliding and all that, but this also provided a lot of information, and this in fact has led to the development of fixed wing aircraft. Next. And from gliders, we were able to know about the thermals, the orographic winds, because they make use of these conditions to keep aloft. And also these were used, all balloons and the gliders during the war used as dropping the ammunition and also for the observations. So it's a multi-purpose recreation, sports, observation for meteorology, and the military operations. So as airborne platforms, all these, though looks very primitive now, have played a very important role. Next. And this is the powered flight in 1913 or so, 1903, in fact, the first, where Wright brothers took the flight for 59 seconds just, but it was a landmark event which took advancements rapidly during the 1920s to have fixed wing aircraft to carry the passengers. Next. This is very popular aircraft which was used to carry passengers during 1920s. Next. And then came the Second World War, and we had a quantum jump. See, all these aircraft at that time were flying in the up to 5,000 feet, that's all. But the bombers really took us to the next level. They were flying at 15, 20, 30,000 feet. And they had a long duration, 6 to 12 hours they could fly. So you require not only the local weather, which was required for the earlier type of aviation activities, you require intercontinental weather, wind conditions up to 30,000 feet and all that. So these all required observations to be upgraded. So the radio sound, earlier the pilot balloon came, and then the radio sound came, and the discovery of jet stream also, the circumpolar jet stream also came from the feedback from bomber aircrafts during the Second World War. And many of these bombers were operating from India. In the Northeast, the US Air Force was there against Japanese, operating from many airfields in the Northeast during 1944, 45, 43. So this, the inputs given by these was very useful to understand the nor'westers, because that was a major challenge to the forecasters there. So they brought in radar. In fact, 1944, US Air Force brought in first radar in the country, military country, which was installed at Kalaikunda, which is next to the Kharagpur, then Chabua next to Dibrugarh, and also in Bangladesh. So these is the early observational tools which we are now using were used during the Second World War. Next. So this is the Boeing Bomber 17 Flying Fortress, which is very popular. 13,000 aircraft of this category were manufactured, and crew of 10 flies this, and its ceiling is up to 35,000 feet. So this is the real challenge for the forecaster to provide met services for these aircraft. Next. And then we came to the jet era post war, and well, now the flights were going up to 50,000 feet. They were intercontinental, 6 to 12 hours they used to fly, and we require data from not only from within the country but also globally, and the forecasts were have to be of the longer duration. So this is again a quantum jump in the observing systems, and the forecasting was come up with the jet eras in 60s, 70s. Next. So jet engines, intercontinental flights, higher latitude, long durations called for a global forecast and guidance. So this is where the first, we earlier had a lower atmosphere, then came the bombers, and then the jet. The physical area also increased, and the type of data or services they required also increased manifold. Next. And also, along with this, in 1944 onwards, the weather reconnaissance aircraft, which plays critical role for the US for monitoring hurricanes and the typhoons, has been there. And along with this, many of the research aircrafts also came, which have played a very important role. Instrumented aircraft for providing understanding cloud processes, weather modification, and also the boundary layer properties, the wind shear. So all these things came up during 1950s, 60s, and which continue to be used now with the advanced aircrafts. Next. Now, apart from what we provide, many of the feedback given by the air crew to the meteorological community has exposed us to these phenomena, which probably sitting in our offices we wouldn't have been able to do on the sitting just on the charts. So how to correlate our analysis with these phenomena became very important, and many of these studies have made us understand why do the rotors take place, what are the orographic winds, the clouds formation of different type which take place, and the overshooting cumulonimbus cloud, the mountain waves, jet stream, and the associated cat, the icing, aircraft icing, the inversion which takes place, associated fog conditions, low level wind shear, microburst and gust front. So I must say that we are thankful to the aviation community to tell us these are the phenomena. Please study, understand how do they form, what, so, and their forecast. And similarly, the observations also. Next. So this is the famous microburst, which in the airfoil, the airfield is even most devastating phenomena which occurs. Diameter of 4 to 5 kilometers, but the divergent winds on the ground plays havoc with the landing aircraft. Next. These are mountain waves with the era of satellite. Now we are able to observe them in or many areas and can warn the crew about the presence with these waves. Next. Now the CAT, with the recent incident of Singapore Airlines, where the 21st May, we lost one passenger and 20th were severely injured, or Myanmar, the aircraft was coming from Heathrow to Singapore, got diverted. And not only that, though it was not, came in the much in the news, the Qatar Airways also held had a CAT incident where 12 passengers were affected. And there is a University of Reading study which shows that between 1975 to 2000, there has been 55% increase in the CAT. So this is where is alarming, because this is associated with the climate change. So we have to be really now work because detecting in-flight CAT is not yet possible. Because type of instrumentation which required are very costly, so cannot be, and very heavy. But yes, maybe in the coming future, but till then, we have to develop our capabilities to predict the CAT. Next. So airborne observations, apart from the initial very localized to now, the pilot balloon and radio sonde, all these were directly driven by the demands from the aviators. And of course, we have now the aircraft which provide us the feedback about the wind temperature and the various weather conditions in the form of ARUP and AMDAR, which we'll see further. And then, as I mentioned you, the research aircraft play a very important role in understanding the weather phenomena, and the reconnaissance aircraft about the severe weather. Unmanned air vehicles are another source of very important useful information, and a lot of work WMO is doing to come up with the uncrewed aircraft systems, which the experiment is going on. So this is again going to be a path-breaking observation platform for us. Next. Now, in the future, this is what has happened, but now we are going to see a revolutionary change in the way the aviation operates. We had these supersonic aircraft earlier also, but their boom and their were not very effective, and they were discontinued. But now again, with the new technologies, the supersonic aircraft are going to come up, and they will require very high level the winds, temperature, and the forecast. Next. So these are the ongoing developments which are taking place. Next. Now this is the unmanned aircraft system. It is improvement on UAVs, and they expect this to really provide you a very useful information in the real time, or the targeted areas where you expect some development to take place as an input for the early warning. Next. This is advanced air mobility, which they are targeting as a medium of transportation within the urban areas and surrounding areas. and also the delivery like Swiggy and Zepto also can be done by these platforms. And all these will require very localized weather information in the forecast. Next. Okay, and now coming to the observation. I missed probably one, the space flights are also now both for adventure taking place, and this frequency is going to increase. So we have to also know about the space weather. So observations, the surface, upper air, radar, satellite, and aircraft, all these provide very important inputs for us. And we all are familiar with this, that how each one has improved our capabilities to monitor the weather and use them in data assimilation and improve forecast. So this is, I think, has been the radars in 1945-50, satellites in 60s and 70s, and aircraft platforms now, the AMDARs in the recent years. So there has been, I think, real revolution as far as observing systems are concerned. And of course, on the surface, automatic weather stations, CWIS, which provides us valuable information in real time. Next. This is what the commercial space flight is, and tourism is going to be a reality. Already 15-20 people have gone into space, spending $20 million, but then many more such are waiting in line, and will be ready to provide weather services for these people also. Next. Okay. Now, so what all we are having, the observations, which are, as you must be already seeing in IMED, all airports are now being equipped with CWIS, DCWIS, RVR, and you name it, which we could not dream it some, say 10 or 20 years ago. So that's a real great part of it. And similarly, not only the airport part, we have in all platforms, very good observations taking place. So to complain that we don't have data or we don't have observations, yes, there always will be more demand, more AWS, more radio sound and all that, but then there is sufficient data for us to work and provide a good service. Communication has revolutionized from snail mail, where we used to send by postcard our weather information, to the telegraphs, to computing now, which is supercomputing, which processes the data, and all this is improving the services. Next. Okay, so this was the first flight which took place, and the demand was so much that within 2 years we have to start the upper air observation. So in 1930, from the upper air stations in Agra started, and then there has been paradigm shift from the manual observations. Earlier, everything was manual. I think the Met observer used to go to the observatory, observe, take the data, come back, write a report, and send on paper to the ATC part of it. And this has been happening till recently. In fact, even now, in some of the airports may be following this system where they don't have automatic weather stations. But then this is positively a big step, where we are now able to have RVR kilometer inbuilt in this system. It gives a lot of confidence to the, not only to us, but to the operators also, to have this data. And I'm really happy that rapidly IMED is doing this work at most of the airfields, and I'm told 18 AWS are in the process of being installed at all the airfields. This is really great. Congratulations. Next. So earlier we had hourly observations, and the location of observatory not representative of the runway conditions, and two important parameters which are required for aviation, the visibility and cloud ceilings, were subjective, not instrumented, and so all these were limitations both for forecaster and also for the aviator. Next. So we did start having a modernization depending on the technology available from 60s onwards. Till then, it was totally a manual system. So in Debenham Airport in 1966, first transmitter, followed by scopograph and oscillograph in 73, 74. And then the MWOs came to organize a system of structure of the aviation met services in the country, MWOs, AMOs, and aviation met stations. So this is a very, I think, robust organizational system which is operating. But we have to strengthen our AMS, aviation met services, because these airports also are going to provide a lot of activity in the future. So either we have to upgrade them or enable them to keep with the latest. Next. So now airport see from the Stevenson screen and when instrument there, we have now almost all parameters which can be through automated instruments we can observe. RVR, ceilometer, winds, temperature, rainfall. So it's a great thing. Next. So we have aviation weather observing system automated at the airfields, and not only at the airfields, even the helicopter operations are increasing. So we have 10 I think helipad AOS. So this is very good, particularly in the mountainous areas where weather changes very fast. To provide these information, I'm sure will reduce the accidents in the mountain areas, and maybe much more can be planned. Next. So this is a really treat to see that at Palam Airport you have got so many RVR systems operated both end of the runways, central line part of it, multiple runways. So this is really good. So and that helps in the marginal visibility conditions where I think operations in almost nil visibility have to take place. And as the density of the aircraft increases, you can't keep longer durations between the flights and all that. So all these help, these observations on the ground on the runways help in the faster turnover and safe turnover. Next. So these are the disseminations. Everything is in real time. The RVR information, the short range forecast, trend. So this is a very good service. I'm sure the aviators, the user agencies are benefiting. And earlier we used to send a meta handwritten to the ATC tower, and on telephone people used to ask us the weather, and so that was not a very satisfactory arrangement. So this is no doubt very important and very user friendly system. Next. So these are the upper air observation. As I told you, the pilot balloon started in 1913, soon after the first flight. Then as the flight level increased, the radio sonde came during the Second World War, and in India 1967. Wind also came depending on that. And we have wind profiler, which is required for low level wind shear. I think MOU with ISRO will help us. We are also trying to get the microwave radiometer for humidity and other measurements. And the aircraft AMDAR and AirUp, I think they are doing next to the satellite very useful inputs to our NWP models, and also for the local forecast, if we are able to get high density local airfield information from the AMDAR aircraft. So this is where the challenge lies now, which in the Europe and US, they are able to study the diurnal variation of the boundary layer based on the AirUp data, because from radios only you have got just two observations in a day, where here you can get 3 hourly or even hourly observations. Next. Okay. So the radar, which is now the most powerful tool for detection of severe weather, local and even the areas severe weather, and it is not only for the aviation but for the general forecast also, and it is also being used for urban forecasting. The nowcast, which I made use for daily, I'm sure uses the radar part of it. It came as a byproduct. In fact, during the second overall military radars, they were their targets were being obstructed by the rain echoes, so they wanted to eliminate the rain echoes, and that gave the meteorologist a tool that how do we use these rain echoes in our weather forecasting. And luckily, post-war, all these military radars become redundant, So they were provided to the research institutions and the meteorological organizations, and they configured this for weather. So this is, I think, one big breakthrough for the observations at the airport. And in India also in 1952, we got the war surplus radar. And by 1954, we had a commercially radar, X-band Decca radar, followed by Raison records at Delhi and Dum Dum. And then 1975, S-band radar started. And then we had 2002, the Doppler radar at Chennai, the Gamotronics, followed by 2008-10, the radars. And now we have got dual pole radars during the 2010 Commonwealth Games. And as we'll see next, thanks to the modernization, we have almost entire country covered by the radars, including the Western Himalayas. So we have, I think, 37 or so 39 radars existing, and we have the projection by IMED is that it will be 70 radars by 2025-6. This is a figure given by the Gajendra in his presentation, so it seems to be authentic part of it, and I'm sure this will fill up gaps at the vital places, particularly in the Himalayan region and also areas of the regional game. So this is going to be a big gap, not only for the aviation meteorology, but also the general meteorology and the urban and the local weather monitoring and the forecasting. Next. Well, met communication, as I told you, we used to wait for have this the postcards, weather being sent, and then the telegram where it was given a higher priority. Then telegraph came, wireless communication, and during Second War, Met wireless broadcast started. MCC in Mumbai used to have teleprinters. Hospital people used to sit there and punch the data, and we used to get. So this is people of this generation cannot imagine that how our predecessors worked in such a challenging situation without data. They are supposed to forecast, but now you got data on a click of a button, and so much of data is available, and use them optimally. I think it's going to be of great help. Next. Now we have got all this. I think you all know about the GTS, JISC, WIZ, FTN, AMSS. Whole lot of it is there, which is really working as a backbone for the exchange of data in real time. So it's a great thing. And only thing is that yes, our telecom people have to keep them on and with the redundancy inbuilt, which is as such is built in the systems, but also to be ensured with that. So next, you can continue with that. Yeah, continue. FTN, AMSS, all these I think I have taken from the IMD only. So next. Okay. Now coming to the aviation forecasting. So though first flight took place in 1911 or so, and in India, and the first forecast was for the Royal Air Force operations in 1921, given from Simla. So sitting somewhere else, you are giving forecast on Vajistan, and also it started. It was northwest frontier, yeah, and also in the Peshawar and Quetta in 1925, and Delhi and Calcutta 29. So 20s because of the insurgency in Afghanistan and northwest frontier, military operations were taking place by the Royal Air Force, and these forecasts were being provided. And you can imagine what limited data was there. Hardly any observations part of it, but then Met officers were doing a wonderful job. Thank you. Next. Okay. Now, post World War, during the World War, I told you is a phenomenal growth of military aviation, both Royal Air Force and US Air Force, long distance bombers up to 6,000 meters. And they demanded real information. You see, having served in the Air Force, whatever you have, but the demand is very precise. You cannot just go and talk something loose. If you say something, they'll come back and take you down. So the debrief is so precise, so you have to be up to it. So when these people operating in the Northeast, first time Northwestern studies were done by these people, apart from the Indian. They brought their radars. They said everything was provided in remote areas. But then again, this demanded a very good quality services within the available resources. So we have to maximize our observations and provide a good quality service. This is what the aviation demands. Next. Civil aviation started in 1950s across intercontinental flights. BOS started, and then our network of radio finding stations started developing. And by 60s, we did have a good amount of data, and the forecasting centers in Bombay and Calcutta were started to provide the documentation. Next. Now, the forecasting challenge with these were that in the beginning, we were doing just local forecasting for the limited area, but now we have to think of the global. So your analysis, your data, and your understanding of the global systems and the features was required. And similarly, the requirement of each type of aircraft is different. It is not that one forecast दे दिया सुबह आकर बैठे आराम से and everything is okay. No, for each type of aircraft, light aircraft, medium haul aircraft, high level aircraft, bomber, transport, all these have got very specific requirements: crosswind, wind shear, clouding. So you have to cater for this. This is challenge part. And of course, the nowcast is important, but then you do for long haul flights require a longer forecast, particularly the types and all that which are there do require, because your planning starts well in advance for your flights. So this is very important. You may think that nowcast only in the aviation. No, many of these flights are planned. The aircrew is planned type of like now we do the refueling in the Air Force, over the ocean. So for that you require a very lead time part of it. So this is very important. And of course, it's not single hazard that you cater for. You take off from one place, one type of hazard is there, en route is maybe second, and when you are landing, there could be third hazard. So all these have to be understood by the forecaster and used in his analysis and the forecast. Next. Of course, in last 50 years, it is seas change. I remember when I joined, nothing was like this was there. There was no new NWP, there was no internet, no supercomputers, no radar, no weather satellites. Still we operated, and but now you have got almost all these facilities. There is a radar, which is a network dream come true is coming up. We have got weather satellites, our own 15 minutes interval, supplemented by other satellites. You have got supercomputers to process the data, the internet, and of course the numerical weather prediction, which was primitive in 50s and now is the state of art. No doubt, always there will be need for improvement, but then we are to provide the operational forecast based on these. Next. And now we are working on high resolution global models, 10, 12 kilometers, maybe coming to some single visit. Ensemble prediction has become a key to forecast, with the extremes being brought in there. And we have mesoscale models which are sub-kilometer, few hundred meters. And now the future lies with so much of data, how to synthesize them, artificial intelligence and machine learning. And of course, the social media, which is going to play a very important role, both for crowdsourcing and also for dissemination. So this is how we have to effectively use them. Next. Okay. Now, this is what I liked about this, the SOP. They have provided forecasting guidance. It is up to the forecaster to follow or not is a different part, but yes, I'm sure supervisors should insist when the people are working. It's a very good guidance provided in this SOP, part of it for the aviators. And you have to think, so look at the big and bring it to the local. This is what is important part. Use all available information from the global models to the synoptic analysis, vertical profile. So everything has to be, but the most important thing which is which is highlighted in this SOP also is, all this is good, but ultimately it is the local forecasting for your airfield which you should master. You cannot sit here in the office and say that you know everything about one column or subdivision. There are local features which play a very important role in aviation, and people have to know about it. Next. Okay, so these are the application of radar. There are many more, so but then for aviation, maybe these are important. And let me again tell you about our predecessors, which you may not know. They were knowing the importance of that. 1961-65, L.S. Mathur, Rao, Kulsrestha, and of course afterwards Raghavan Sahib, and whole series of thereafter. Maybe you know much more. They were our colleagues only. Pradhan, Suresh, Thampi. Many of them have done a wonderful job in radar application in aviation and other part. I am sure, I find that even now the younger people, some of them are doing very good job. We should encourage them, because it is such a wonderful platform. The radars provides you so much of information, and if you don't use them optimally and effectively, I think we are not doing our job. Next. So this is what the station consideration, which the forecaster has to do it. And it is very well brought out that yes, we have to know our topography, peculiarities. See, at many airports, two ends of the runway have different visibilities. So you you should know why these visibilities are taking place. The winds are different. So all these are very important, and for this you have to do a lot of local studies. It cannot be sitting writing a large scale paper will be able to solve your local problem. So you have to do, and there were a lot of studies done in 60s, 70s and 80s for the airports. If you see the Mosam, thunderstorm, visibility, rainfall, winds, lot of studies, which I am not sure whether, because now maybe you are looking for high impact papers. So, but the local studies needs to be encouraged, because it is only the local hints and local forecasting which is going to play a very important role in aviation part of it. So my appeal to all of you is there. Please look into, and you have got a wonderful set of data. You can do a good quality papers even with this data. Next. So this is the part that, okay, next. So we are already, go back. So radar has been, as I told you, there are a good number of studies. And we now have what mesoscale models with rapid simulation update cycle of the radar data is being provided by you, the satellite, the AWS data, all this is there. And we have got nowcast tools also, which can be improved upon, which needs to work on this. So there should be a targeted group to develop these nowcasts and enhance their limit from 2 to 3 hours to 6 hours, 5 hours, 6 hours, which is now possible with the type of data which is available to you. This is very important challenge. Next. Now, as I told you, there have been a good set of work done by our meteorologists. So this is, we had under Sama recently a lecture series on radar is going on, and we are thankful to all our radar specialists to deliver lectures, Dr. Pradhan, Thampi, Kundu Saab also will come probably, then Suresh, and also the Kannan delivered a lecture. So they have shown various signatures which can be used. Doppler spectrum width, which is very important, which is used for nowcasting of thunderstorm and turbulence, is study by Suresh at Chennai Airport. So I'm saying with the existing data and past data, with the analog radars, people have done good studies. Now we have got dual pole radars, and so we should expect good quality work happening there. Next. This is where the early precursors of MaxW is able to provide you a lead time of which is in the nowcast scale about the Z enhancement and the severity of weather. Next. Okay, now this is what is there and what is present state. You know much more than me, so I'll not be able to comment upon, but I'm sure with all modernization which DG and his team is providing to you, aviation met people, a lot more is expected, and I'm sure you'll be able to deliver. Now, these are the things which the AMDAR part of it, which was limited earlier, but now it has become a very powerful tool. And I'm happy that India also is thinking of making more use of it. It's not that you are not using it, but it's not, as my understanding, is not satisfactory. Next slide. Next slide, please. How come this has come here? Okay. Now this is about the weather part of it, the forecasting. There have been, as I told you, depending on the availability of data and the resources, we have been developing our information system in Indira Gandhi Airport. The fog information system was developed, which has both current weather and the forecast provisioning to the users part of it. Next. The fog part, I think this is a good example of in-house development to understand the processes part of it and to forecast. But I think the user should closely work. The science part is very important, but it's application and the quality of the forecasts which are being generated, how good it is applicable have to be there. So I'm sure the IMD is closely working with them. And similarly, the development of this daily model on with the chemistry by NCMRWF, they are claiming to be the promising part of it. So I'm sure IMD will be working with these group to improve the fog forecast, because this is going to be perennial. Every winter, you have to have this this challenge of forecasting fog, and we need these efforts to continue. Next. Okay, now this is the AMDAR data. Now this is now proven by number of papers, studies and calibrations. This data is as good as radio sound data. But the beauty of this is that its frequency is very high. Cruising level, it is enormous. Amount of data is there. It is in million of observations. But even the vertical profiles at the airports in Europe and US, as I told you, they are able to generate hourly, 3-hourly profiles, which is not happening in I think, developing countries for various reasons, because I think some payment issues also involved. But then let's work on this, because this is going to provide us a cost benefit advantage as far as the AMDAR data is concerned. Next. Now, this is what the benefit is there. It provides us very improved weather systems, weather part of it. So almost anything which we are now looking forward, it augments the monitoring and prediction of weather systems. Next. Now, this is the contribution of AMDAR data. It comes fourth as far as the data utilization. Of course, the satellite takes the very high precedence, but then and it has contributed to 10% improvement in the forecast. So this is a very promising part which we should work on it. Next. This is the radar data. You see the green filled up for Europe and of the US, and even very high density of Europe, but hardly any flights which is there. And this is, I think, of the study which we was done in 2008. Part of it. Next. Okay. Now, in 2008, a preliminary study was done use of AMDAR data. It is a Mosam paper which is there, which says that 10% improvement. It showed improvement, not subsequent, because only 2 weeks of data was used in this study, which was experimental program. Qantas flights were used, part of it. So this is the first study which was done in India in 2008 using part. Next. Okay, now this is a recent paper by the NCMRWF team led by Indira Rani, which has very elaborate analysis of the AMDAR data has been done based 2000 to 2004 years data, even during the COVID data, when the data came, COVID period data came, it has been there. So this is a good study, a part which we should go through and make part. Next. This is a paper which has come in QJRMS in 2023. Next. So here the right hand side shows that Arab data, the increase in the Arab data has been significant now in the recent years, and that is making difference part. But the data, otherwise AMDAR data in flight is okay, but as far as the low level data, takeoff landing data is poor. Next. You see the data density or US, and hardly any data, very limited data at other parts of the globe. And they are next. Here again it shows the figures are given, the Arab data, the AMDAR data, and WIGOS AMDAR data. In WIGOS AMDAR data, the all national Met services provide this data to the WIGOS, and AMDAR pure data is a data which is, so this 10 times more data which is being on the WIGOS platform. Next. Next, you can go. So it highlights again here that AMDAR is now a very powerful platform. It is improving the forecast performance by 10%, and it comes close to the better than and close to the radio sound observations, and it cannot be. It is it's a globally which is the data is going to be available. Next. This is a summary. You may go through it. It says the part of again related to the AMDAR data. The need is highlighted that we don't have sufficient takeoff landing data from the AMDAR as of now, but I think there are some meetings planned with in this respect, and I am sure this data, which is going to be very important for aviation forecasting and general forecasting also, will be made available through the AMDAR. Next. Well, this is another thing which is going through WMO is going already. This is improved version of UAVs, the unmanned uncrewed aircraft system, and demonstration campaign is going on, and this is going to provide a lot of data, observational data part of it. So we should keep track of what is happening, what are the outcome of this experiment. And there are already many countries, this is a voluntary program where various aviation companies are participating, research organizations. Next. This is a WMO uncrewed system which is there, and aim is to improve the global observing systems by providing the data. Next. So there are 24 research institutions are there, 10 countries, 14 industry partners. So it's a big program, and I'm sure some worthwhile observing platform can come out of this. Next. Okay, another last 2 or 3 important areas which we have to be, these are going to be very important, the climate change. One is the aviation does contribute to the global warming. 2.5% of the CO2 emissions are from the aviation, but they are working to have a fuel efficient, the CO2 efficient fuel, and hopefully that will bring down some CO2 emission. But the climate change and variability of extreme weathers are going to be challenge for forecasters. Already you see sudden downpours at the airports creating havoc, and because of extreme weather. And apart from this, next slide, please. So these are the impact which is already being identified. Sea level rise in the small islands and the coastal areas, increased intensity of storms, high temperatures. This is going to be very critical because it will reduce the payload. A longer length of runway will be required. And now you will be people who are not familiar with the implication of this. On a clear weather at many of the airports, you cannot take off, particularly in the Leh, which is in high altitude. After 10 o'clock, 11 o'clock during summer, there is no takeoff possible because air is thin, the takeoff length increases significantly. So this is there. Even if it is, you are able to take off, there is no payload where empty aircraft has to come back. So this is where it's going to be very similarly heavy precipitation, the flooding part of at the airports are there, which is happening in India. Many airports do part, and change in wind will have a challenge about the routing of the aircrafts, and the CAT is another important which is part. Changing icing conditions will be there. Interconnection and the hubs, if they get affected, all and the aviation gets disturbed. So these all are the challenges which are going to be there, and we have to be ready. What it calls is a improved prediction and of these events. Because and not only the climate projections which are going to be there, which is going to be very important for mitigation and adaptation and the resilience part of it. So we have to really now start working, and each airport will be different requirements. It cannot be general that global warming uniformly it is going to affect all airfields. No, so again this requires local analysis part of these climate change impacts. Next. So this is the pictorial part of the impact taking place. The winds, the temperatures, extreme weather events, all these are there. So next. Now the WM has done a very detailed survey about the aircraft performance, airport performance, that how the climate change is going to impact part of it. So they are also now going very systematically. This was done in 2021, part of it. Next. So infrastructure, operations, management, safety, airline operation. So all these things, how the climate change is going to be and variability. Based on this, they have come out recommendations for the National Met and Hydrological Services to work on climate change, very and its impact on aviation. Next. So we have to provide. See, it amounts going to amount a lot of money for any decisions to take place. So until it is based on the best scientific advice and it needs to be downscaled to the local conditions, and then only the good adaptation, mitigation, and resilience programs can take place. And what they are really keen is to know in next 10 years to start with, and then 10 to 30 years part of it, where they have to do some infrastructural changes or other operations. Next. Now, this is the third part, which is which we have to look into it, the space weather. I'm not sure whether India Met Department is working in this field, but many of the National Met services are already working and issuing the space weather advisories. And WMO partners with the ICAO to set up these regional grouping which provides space weather advisories, because it affects three important aspects. The navigation part is very important. The radiation itself is a health hazard, and safety part of it, and also, so these are very important things which are going there. And as you will see that a lot of flights from India, it happens primarily in the higher latitudes, and many of the flights from India are circumpolar. They will get affected if any of these solar activities take place which affect the space weather. So we need to understand. I'm not sure whether the ISRO is going to be responsible, but ultimately it has to fall to the IMED. Next. So it causes disruption in communication, navigation, and surveillance system all, and elevate radiation dose at the flight altitudes, which is health. And there are three types of storms: the solar storms, radiation storms, geomagnetic storms, and solar flares. As far as advisories, they are given in the 5-point scale from severe to no event, minor to extreme events. So these advisories are available. Even if we don't do it, at least while giving forecast of or any flight is going circumpolar, we should know about these. So maybe some training in the space weather may be planned. Next. These are the manifestation of geomagnetic activity. Next. These are the wonderful pictures of the northern hemisphere and southern hemisphere. They are good to see, but they may have hazardous situation for the aviation. Next. These are the circumpolar routes which from Delhi to US and Canada go through the polar regions, and therefore we have to keep track of these situations. Next. So these are the designated ICAO centers for the space advisories. There are 4 global: Pegasus, which is European consortium, then Australia, Canada, France, and Japan, and NOAA it itself does everything. Then there is a China, Russia consortium, and of course South Africa has got a regional center. So these advisories are available. Whether these are being used by various national services, I'm not sure, but we should start considering that to use these advisories. Next. Okay, this is the last part of it, is a world area forecast system. You all are familiar, but there are significant improvements are taking place. In fact, next 4 years are going to be very significant. Already this process is started from 1.25 grid points to degrees to it has come down to 0.25, not 0.25, 0.25 degrees part of it. So significant increase to provides winds, temperatures, and also the icing, turbulence, and the cumulonimbus cloud fields. So all this is there. Next. Okay, the forecast, significant forecast also will be up to 48 hours and 3-hour intervals. So you have a periodic updates there, and how the weather is going to change also. It's not one forecast which is there, part of is there. And they have merged. Earlier used to be medium level and high level SIGWET forecast. Now it is the one which will cover from flight level 100 to flight 160, 600. Now, another important thing which are going to be there are going to be many more vertical levels and time steps. And also they are going to introduce the probability forecast by 2028. Next. So these are the 54 levels in vertical for temperature, humidity, and wind. And there are 10 odd levels for the turbulence part of it, icing, and cumulonimbus cloud. Next. These are the earlier, they used to provide mean and the maximum severity of the icing. Now at each level, they are going to provide you a deterministic icing forecast. part of it. So this is what is there. Similarly, for the cumulonimbus cloud and the turbulence will be there. So they are going to be there. I'm not sure whether OLBS will be aligning itself to these type of products for Indian and South Asian countries. Next. Okay, next we can go. Yeah, this is for that turbulence part of it. Both orographic and the CAT it does provide. Next. You can see here 5 categories of the turbulence is there, and the red one is the severe one, which is over the mountains of Argentina and Brazil, South Brazil. Next. Now this is the timeline for futuristic, where the probabilistic forecast will be introduced by 2028, and rest all are going to be 2024, 25, 27. So please keep track of them and make use of our forecast systems. Next. These are the probabilistic forecast which will be coming up in different categories, a part of it. So this is another keeping track with the what is happening otherwise in the forecasting fields. Right. Next. So finally, I think to sum up, IMD is doing a fairly good job, but there is always improvement, and to keep pace what is happening is equally important, because some of them take long time to materialize. It's not overnight things will happen. So we need to start planning well in time. A lot of planning has gone, and I'm happy that many of these are already implemented. So to start with, I'm sure part of the IMD's Vision 2047, there will be specific mention of the aviation met services. You cannot work on annual plan or short plan. You have to think of this. And all this is good, but we don't have really support of the real national R&D center in aviation meteorology. You can do piecemeal work, but no world-class work can be done without considered effort. So we need to have this part of it. Of course, we continue to promote station-specific studies, very important. And also a lot of urban network is being developed. They should not be isolated. The airport is an important part of the urban meso network. So how do we integrate airport meso network with the urban meso network and make use of aviation forecasting? And of course, as I mentioned earlier, artificial intelligence and machine learning are going to be, because we've got so much of data, we really don't know how does it really can be applied to the aviation part. So that is another area. So Dr. Mahapatra, I was mentioning that two important. One is that I'm sure you are including aviation met services as a part of the Vision 2047. And there is a need also to think of setting up a national R&D center for aviation meteorology. It could be not only the IMD, the Ministry of Civil Aviation should support it, armed forces should support it, the academic institution. This is the need of art for any futuristic good quality research and support to the services. So a part of the aviation met services Vision 2047, this could be looked into. Next. You have got very good organizational structure, but here again, as I mentioned you, the R&D part is missing. Functionally, you are doing a good job, but improvement development, which is long term, needs to be also integrated in the system. Next. Okay. Upgradation of observing systems at international airports. I think you have to have already planned very good. If they are missing, please do it. But also we have to go in for the all other airports also, which I am happy that 18 of them are coming up. But no airfield should be with the left to as a manual observation. We should have automated weather systems, at least DWEI, because winds are very important. It should be there at all airports. Space weather, some understanding of space weather and some training in space weather should be built in. And of course, densification of AMDAR data, particularly the takeoff and landing, should be considered. And of course, climate change, which is perennial, its variability and its impact on aviation at the local level needs to be worked on and side by side. So with this, I wish all people using aviation a smooth takeoff and safe landing. Thank you for giving me this opportunity.
Thank you, sir, for very insightful talk. You have covered almost everything from history to current affairs and also given the future guidance and a lot of ideas for the research work for the new generation. We can take up few questions from the audience. Online, those who have joined online, they have two options. They can write their questions in chat box, or they can raise the hand and ask the questions.
Okay, in between you can.
Yeah, I
Mr.
can
Pai.
just start. First of all, I thank Tyagi Saab for taking all of us to a very informative and a beautiful ride through entire historical, aviation services, various technologies to the latest technologies and what are the latest, development, not only the in the atmospheric travel, even outside our Earth itself, space travel, and what are the latest technology. So I would like to actually make one personal comment and also a small query with you for your comment. The first thing is that, sir, actually, I remember when you came 2008, I also was after Dr. Rajivan left LRF Finchar. So I had a very long thing and working with you. So you had actually a lot of development had taken place that time, NWP and modernization of entire NWP division, whatever it was done, and even NWFC, the room with the video wall and all, a lot of development. I still remember many of them got further improved, but I think still some of them, since it did not get, still it is working. Abibi, I say actually, it's very good since that, you have been a infrastructure man, contributed a lot. And also another, I would like to remember that SASCOF 2010, you had, from ICTP meeting, still it is working well, that beginning that you had made. So that is about just, personal mention, which I said. Coming to, today's topic that you said. Actually, as you had correctly said, there has been a lot of fast changes taking place in spite of all the technological development coming in the aircraft itself. Weather and climate is very important for aviation. So aviation meteorology is very important. Several type of aircrafts are coming. We have to look for space. And though you have mentioned about the observation, how to make use of observation in NWP and other thing, what I felt was that, as an IMD being a organization which is providing meteorological services to entire aviation. So what is your opinion that what specific development that should take place in IMD? For example, this is being a very specialized job providing aviation meteorology. Do you think that we should have a capacity building, continuous capacity building, and a very specialized, center itself is necessary? Those who will be very expert, because things are becoming so fast changing. We cannot simply bring a person on transfer and suddenly teach him. So how you are viewing that we can have a very specialized stream in the aviation within IIT? That's all. Quick.
There is no denying.
Yeah. I think, sir, you can come on a question.
Okay.
Any other questions? Any other comments or questions? Yes, Mr. Janam.
I was sir looking that for vision. So India, whatever development we have done in aviation. So how we are leading either Asia in future, or whether we are in a, state of art system, like we have two, global model. So as you know, many countries, they may not be, the vast product and others. So can we be a center for, say, world area, focus center, create, because similar product we are generating actually, to see. So that is one. And second part, as you know that, in ICAO and WMO, our, presentation or leading a specific part is, need more attention. So this two. Yeah.
Okay. Any other questions or comments in the chat box? Just check the chat box. Gajendra, do you want to have?
Thank you very much, sir. Really, that was a very comprehensive and
Okay.
sir, many things we learned from you, and the things you highlighted what should be done in future. We'll take care of this thing. Yes, we have in the last 2-3 years we have focused more on putting that digital current weather instrument system and the RVR system at the airport. So that also we have already completed at all the wherever the some I think out of 100, so more than 85 airports we have completed. So all the airports are equipped with RVR and the DCWIS majorly, which are remaining are unavailability of sites due to some other problem. And one of the biggest ambitious project, that was the 18 AWAS, that was conceptualized by you self. Now we are finishing, and we have installed the system at the 4 airports, and in fact we will be doing the site acceptance test next week, and will be so next month we will be making operational those 4 airports with the 18 AWAS, and all those will be completed within next 6 months. And apart from that, yes, there is a requirement of now we have to focus more on that, like wind data over the airport, wind profiler, or the Doppler with the lidar, or low level wind shear alert system. Now that's our next future requirement. And also IMD has to work for this something for the space weather in future. So we will focus on these matters, and capacity building, and highlighted by you. That's what. Thank you, sir.
Sinha sir, you want to speak?
One,
Any audience comments?
On करके sir.
On करके बोलो.
Mic on.
Sir, we have a question by Dr. Satyaban. He's referring to Singapore Airline incident, and he's asking how it can be avoided.
Sir, now you can respond. Yes. Some questions are common.
Yeah, okay. The first and foremost is, as I told you that about the aviation med services, the observation is a cornerstone. So depending on the type of aviation is going to be there, you have to develop that capabilities. Because that is required not only for forecasting, even to the current operation, and the confidence of the user comes if there is a if he knows there is no authentic or instrumented observations, then his confidence comes down. But if he knows precisely what is RVR, what is cloud height is going there, his decision making becomes. So observation is very important, critical part of it. And then the first level, of course, is critical is the nowcasting. Nowcasting, you may say that yes, the trend you can give whatever you feel like, but it is not so. And the limit of nowcasting also from 2 hours, it is now needs to be extended to for 5-6 hours, because people have to take diversion decisions well in time. They don't have to come overhead and then divert part of it. So the third thing, which is most important, is to how to make best use of the so much of information which is being generated. Now for that, again, the capacity building. I'm not sure whether within the maybe there can be a career for the aviation meteorologist, but whoever gets trained at the aviation airport for some time, he will be positively an asset to the IMD. Let me tell you, is the most challenging part is to be a forecaster at the aviation mat. if it is properly planned. If he goes and sits there and comes back is maybe different part, but he wants to really involve the demands and the service which he can provide is really, and the amount of resources are available to you with the type of data and all that. So that is part. And for that, capacity building of him, how to use that data, and also the monitoring. Supervisory role also is very important. The mentorship. You can't leave youngster of his own, then he'll do whatever best he can do it. So this is very important. Organized, planned part, refreshers courses, trainings and all that is very important. And how to, you can use him very effectively. Or what various forecasting platforms, whoever is worked in a airport met can be used part of it. So these are the continuum part. All these are important. Observations I have told you is important. The information about forecast is now is lot of them, but how to synthesize them and use local, you should know the local peculiarities. So local studies are very important. I am sure that you can ask each one of them to write one paper for one station in 1 year. Some local case study, simple case study also, if gets documented, it helps the person who goes new. How can he develop without that part of it? So that is very important. So it's very, I think, challenging field, and with changes taking place in the aviation demands and type of this, it is going to from micro scale to space. And different type of platforms which are going to be there, from UAV to the heavy supersonic aircraft, space flights. So we have to think in 2047. So we'll start targeting for this part. Within the IMD, I think observational part you have stage. Now the radar is another thing which is very important part. How are we using it optimally? So that is very important. Just review in last 5 years, so many radars have been put, how many studies have been done? And think of the people who were there with the analog radars, they have done so much of studies, like Raghavan Saab and all that. So we have got now good amount of data instrumentation type of that you can do it. So let's generate a professional, you see, interest and the competition in this, and recognize the good work which is being done by these people. And I'm sure.
Sir, thank you very much for this very brightening talk about the aviation meteorology, the science behind, and the applications in India in particular. I'm sure that the colleagues in India Meteorological Department, the researchers in the Ministry of Earth Sciences and outside, the various academic and R&D institutes would have benefited from your excellent talk. When I think about the take-homes, I find that there are 4 or 5 points. The most important point is that there should be continuous enhancement and upgradation of observational network. There should be upgradation of the modeling system specific to aviations. Here I find a large gap. Even though we have got NW model products, when I think about NW model products for each and every type of forecast issued for purpose of aviation, our post-process products are very much limited. I'm sure from this talk, our NW modelers will be inspired to take up this job and prepare the post-process product for each and every service being provided by IMD towards the aviation services. The third point you have correctly highlighted about the research and development. Yes, it is essential to have an R&D center for aviation purpose. I'm sure Gajendra and Sony, Dr. Patnaik, those who are in the Mission Mausam program, they will take care of it. It will be taken care to establish a center for excellence with respect to research and development. We have to improve our application services. It is not simply the aviation operators, it's not simply the airports, but also the general public who are visiting the airports, who are moving, the crew members, the various service providers, they also need forecast. So therefore, there is no end to our improvement of forecast. We have to improve our forecast accuracy, forecast service delivery. And also we should have a collaborative mechanism with each and every stakeholder working in the aviation other services. So once again, on behalf of all of our colleagues and all the participants in this webinar. I extend a vote of thanks and our gratitude to you, sir. Thank you very much.
I am grateful and thankful for all this.
It's our
I'll also take this opportunity. Dr. Mahapatra had been kind enough to deliver a talk to the South Asian Meteorological Association some time back. So this is what the SRM University and the SAMA has said.
Thank you.
भाई जो ऑनलाइन में है, उन लोग के भी थोड़ा फोटो ले लीजिए।
अच्छा फोटो लेने के
दिया नहीं है।
ऑनलाइन स्क्रीनशॉट करना पड़ेगा, स्क्रीनशॉट लेना पड़ेगा।
Thank you. School papers. So,
One last thing. I know. Please.
Come to second.
Bill, why not? I know. All good.
Thank you.
Thank you. ये सब आपका input है. Yes.
Thank you, sir.
Welcome.
Jogging is here.